Students, in this video, we will discuss hydration reaction of alkenes. Addition of water to an alkene molecule is known as hydration of alkenes, right? So, addition of water to an alkene molecule is called hydration of alkene, right students? Now, hydration is usually proceeded with cold concentrated sulphuric acid to form an intermediate which is known as alkyl hydrogen sulfate. When we boil alkyl hydrogen sulfate with water, it decomposes to give corresponding alcohol. Now let's see how reaction is proceeded. Suppose we have an ethene molecule like this, carbon. We have ethene molecule, right students? Here we have ethene molecule. Now when it is reacted with sulphuric acid, here we write the structural formula of sulphuric acid to show the addition of sulphuric acid. This is the structural formula for sulphuric acid, students, right? Now here you can notice the carbon atom, oxygen atoms has lone pair of electrons, right? This oxygen atom 1, 2, 3, 4, 5, 6. Likewise this oxygen 1, 2, 1 lone pair is utilized in the formation of double bond with sulfur, right? In the valence shell of oxygen we have 6 electron pairs, right? 2 are utilized in the making of double bond. 2 electron pairs are left here, right? Similarly, this oxygen has 2 lone pairs. This oxygen also has 2 lone pair of electrons, right? And this is the partial negative part of the sulphuric acid molecule, and hydrogen is the partial positive part. Now, how reaction is proceeded according to, since this is alkene molecule is symmetrical, right? So to one carbon hydrogen is added, right? And to the second carbon, with doubly bonded carbon, this hydrogen sulfate part will be added to the second carbon, right? So according to this, how addition take place? These loosely bonded pi electrons, they will attack on this hydrogen, right? And they will abstract this hydrogen in the form of proton, and bonding electron density goes to oxygen. Bonding electron density shifted on oxygen, right? And oxygen will attack with the help of this lone pair of electron to the second carbon atom. Here oxygen will attack to form sigma bond with this carbon. Now let's see what is the shape of product, shape of alkyl hydrogen sulfate which is formed. Since it is ethene, so after the reaction we get here CH3, right? Hydrogen is added to this carbon, so it will change to CH3, and pi bond is saturated here. So to this carbon we have 2 hydrogen atoms, CH2, right? This is saturated after the addition of this hydrogen, and this part is linked. How many oxygen atoms are present with this sulfur? 1, 2, 3, right? So with sulfur we write 3 oxygen atoms and 1 hydrogen atom. So this molecule which is formed is known as ethyl hydrogen sulfate. This part is ethyl hydrogen sulfate. ethyl hydrogen sulfate. This is the intermediate, right students? Now how can we get alcohol from this intermediate? Further, we boil ethyl hydrogen sulfate with water. We boil it with water in the next step. This is the first step, right? And now we see what is the second step of the reaction. In the second step, ethyl hydrogen sulfate which is formed, that is CH3 CH2 O. Now we write in this form, that is SO3H, ethyl hydrogen sulfate, ethyl hydrogen sulfate. Now it is boiled with water. Dear students, we know what is the boiling temperature of water. Of course, water boil at 100 degrees Celsius. It is boiled with water. Partial positive, partial negative. This oxygen has two lone pair of electrons, right? So with the help of one lone pair of electron, this oxygen abstract proton from water. It utilizes one of the lone pair to abstract proton from water, and electron density shifted on hydroxide ion, right? So in this way, bonding which is present between this oxygen and sulfur, this bonding is cleaved. It will cleaved, right? So after the reaction, we will have, it is protonated. This part is protonated. We get CH3 CH2 OH. Ethyl hydrogen sulfate, ethyl part after the protonation changes to ethanol or ethyl alcohol. Ethyl alcohol or ethanol, right? And this part, next part, again sulfuric acid molecule is regenerated. I hope this reaction is clear to you students. Now let's see what is the next reaction of alkene. Next we will study reaction number 4, that is halogenation reaction. Halogenation, right? Halogenation means addition of halogen. Addition of halogen to an alkene molecule is known as halogenation. So in halogenation reactions, addition of halogen to an alkene molecule is called halogenation. Halogenation of alkene. Now students, usually bromine and chlorine, they are effectively added to alkene molecule, right? While fluorine is too much reactive, so that's why usually too reactive to control the reaction, and iodine does not react, right? Usually iodine is not added to alkene molecule. So reactions are halogenation reaction is usually proceeded with bromine as well as chlorine. Another important thing is this reaction must be proceeded in the presence of inert solvent. So what is the condition for this reaction students? Inert solvent is required, right? Condition. What are the conditions of reactions, right? First one, inert solvent is needed to proceed the reaction. Solvent must be inert. Inert solvent. What is meant by inert solvent? It is the solvent which is non-reactive non-reactive towards both alkene molecule as well as halogen molecule. It must not react with alkene as well as halogen molecule. So inert solvent is required, and usually we use bromine as well as and chlorine for addition. Reaction with fluorine is too reactive to control the reaction. F2 is too reactive to control, and iodine is usually not added, does not react. Right, students, now let's see how halogenation of alkene takes place. We have an alkene molecule. For example, if we have ethene, molecule, and for example, if we want to add bromine molecule, Br2, we can write like this, Br2, and here inert solvent must be there. Inert solvent. Now inert solvent, if we see some inert solvent, examples of inert solvent will be inert solvent, it will be carbon tetrachloride, right? Carbon tetrachloride may be it is inert, so here we use carbon tetrachloride, CCl4. In the presence of carbon tetrachloride, addition of bromine to alkene takes place in such a way that this one bromine atom added to this carbon, while another bromine atom added to this carbon, right? Carbon number 1 and carbon number 2. So after the reaction, we have the product like bromine is added. Here we have another bromine, hydrogen as well as hydrogen. So we get 2 bromine atoms on adjacent carbon atoms. The alkyl halide molecules which have 2 bromine atoms on adjacent carbon atoms, they are known as vicinal dihalide. Since there are 2 carbon atoms, so we can say it is 1,2-dibromoethane or vicinal dibromide. It is vicinal dibromide, or IUPAC name of this molecule is 1,2-dibromoethane, since there are 2 carbon atoms. Right, students? Now students, we will see the mechanism of this reaction, that is how bromine molecule added to ethene molecule. Let's see the mechanism of reaction. When bromine molecule approaches to this alkene molecule, right, then due to the loosely bonded pi electrons of this ethene molecule, the bromine molecule becomes polarized. This polarized bromine molecule it transfer a positive bromine atom to ethene molecule, right? So how can we write this reaction? We have ethene molecule, right students? Here we have ethene. Now when bromine approaches to this ethene molecule, Br, right, it becomes polarized, partial positive and partial negative. Due to the dislocation of symmetrical electronic charge, bromine molecule becomes polarized, right? Now we see how reaction, what is the mechanism of this reaction? When this molecule becomes polarized, then what will happen? These pi electrons, right, they will attack on this partial positive bromine. So pi electron will attack on this partial positive bromine, and this sigma electron pair which is present between both the bromine atom is shifted on this bromine, right students? So after the reaction we will see CH2 Br. Here there is a plus charge on this bromine. There is a plus charge on this bromine, as well as we have bromidine, right? Bromidine is also formed. Here students, you can notice this species which is formed, it is known as cyclobromonium ion. Bromine with plus charge, it is known as bromonium ion, right? Since this bromonium ion form a cycle with this structure, with straight chain, so that's why this is known as cyclobromonium ion. This is cyclobromonium ion, right students? Now the next step of the mechanism, the second step. This is the first step of mechanism. Let's see what is the second step of the mechanism. In the second step we have cyclobromonium ion, CH2 Br. Here we have plus charge on this bromine, right students? Whenever there is a plus charge in the molecule, ठीक है, मॉलिक्यूल में जब भी चार्ज होता है तो हमेशा मॉलिक्यूल अनस्टेबल होता है, राइट? सो इट विल फाइनली चेंजेस टू by the attack of, we know very well bromide ion is also there, right? So it will this molecule try to remove its electron deficiency, यानी ये अपने प्लस चार्ज को रिमूव करने की कोशिश करेगा. तो किस तरह से इस मॉलिक्यूल से प्लस चार्ज रिमूव होगा? अब देखें यहाँ पे कि both the carbon atoms here, since they are attached with this bromine, so these carbon atoms, of course, they are less electronegative as compared to halogen atoms, right? So these carbons, they are partially positive part of this molecule. So this bromine, with the help of this negative charge, either it can attack on this carbon or either it can attack on this carbon. ये इन दोनों में से किसी एक कार्बन एटम पे अटैक कर सकता है, ठीक है? Suppose this bromine atom, it will attack on this carbon atom with the help of negative charge and will form sigma bond with this carbon, right? So then what will happen? This electron, sigma electron density totally transfer off to this bromonium ion. Sigma electron density which is present between bromonium ion and this carbon is totally shifted on this bromonium ion to overcome its electron deficiency, ताकि इसकी electron deficiency को overcome कर सके और molecule से plus charge खत्म हो सके, ठीक है? Now let's see what product is formed here. So after the reaction we have product like CH2. Bromine is attached with this carbon, right? And here we have CH2. Second bromine atom is attached with this carbon, right? So product is 1 2 1 2 dibromo ethane. So in this way we get 1,2 dibromo ethane. This test is very important test, students, because this test is usually applied for the detection of unsaturation in the molecule. This test is applied, that is test with bromine water. Test with bromine water. This is usually known as test with bromine water. Right? This test is applied for the detection of unsaturation in the molecule. Applied for the detection of unsaturation. In the molecule. I hope this is clear to you, students. Right? Now, let's see what is the next reaction of alkenes. Now, next reaction is known as halogenation. 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 Dear students, first of all, we must know what is meant by halogenation. It is the addition of hypohalous acid to an alkene molecule. Addition of hypohalous acid to alkene molecule is called halogenation. Addition of hypohalous acid to an alkene molecule. To an alkene molecule is called halogenation. Students, what are hypohalous acids? Hypohalous acids, HOX. They are known as hypohalous acids. For example, HOCl, hypochlorous acid. Hypochlorous acid. Now, alkene molecules on reaction with hypohalous acid will form halohydrin. So, reaction of alkenes with hypohalous acid, alkenes on reaction with hypohalous acids will form halohydrin. Alkenes, when react with hypohalous acids, the product which is formed is known as halohydrin. This is the product. Dear students, what are halohydrins? Halohydrins are these are the alcohols which contains halogen atoms. Halogen atoms containing alcohols are known as halohydrin. Alcohols containing halogen atoms. Halogen atoms, right? They are known as halohydrin. Now let's see the reaction, how halohydrins are formed with the help of an example. We have ethene molecule like this. This is an ethene molecule. This is an ethene molecule. Now if we add halogen atom, for example, we want to add chlorine. Dear students, for the halohydrin, if you want to get halohydrin, then chlorination will be done in the presence of water. ठीक है, वाटर के प्रेजेंस में हम इसमें हेलोजन एटम को ऐड करेंगे. ठीक है ना. इसकी क्या रीज़न है कि हम वाटर के प्रेजेंस में हेलोजन को क्यों ऐड करेंगे. देखें, व्हाट विल हैपन, वी हैव हेलोजन, राइट. Halogen, like we have chlorine. If we have chlorine, if water is used as solvent, then first of all chlorine will dissolve in water, because here in this reaction solvent is reactive, right. So we know very well, when chlorine is passed through water, chlorine on reaction with water will form hydrochloric acid as well as hypochlorous acid, right. So hypochlorous acid is required for the formation of halohydrin, right. So that's why reaction is carried out in the presence of water. So how reaction is proceeded in the forward direction. One chlorine atom, actually chlorine when dissolved in water, it form hypochlorous acid, right students. So here it is not written, I'm writing here, actually first of all chlorine when dissolved in water will form hypochlorous acid, HOCl, right. This hypochlorous acid is added to ethene molecule instead of chlorine, because here chlorine first of all react with water to form hypochlorous acid as well as hydrogen chloride, right. So here we will see in hypochlorous acid, since we know oxygen is the second most electronegative element of the periodic table, so this part is partial negative and this part of molecule is partial positive. Chlorine is partial positive, right. So it is a polar adding reagent. But here we can see ethene is a symmetrical alkene, because both the carbon atoms forming the double bond have same number of hydrogen atoms, right. 2 hydrogen atoms to this carbon and 2 hydrogen atom to this carbon atoms, right. So to one carbon, this hydroxyl group added to one carbon, and chlorine atom goes to second carbon. So after the reaction we get the product like, here we have H and halogen added to hydroxyl group added to this carbon, right, and halogen added to this carbon atoms, to this carbon halogen is added. Halogen, here we use chlorine, so that's why chlorine is added. This is known as, the product which is formed, it is known as chlorohydrin. Chlorohydrin. Now let's see one more example. We take the example when alkene is unsymmetrical, then which type of product is formed, right. Suppose if we have alkene molecule like CH3 CH double bond CH2, this is propene molecule. Right students. Now if we want to add chlorine, then we must use water here, right. So chlorine first of all dissolve in water. It is dissolved in water to form hypochlorous acid. Hypochlorous acid which is formed, this is the partial negative part, since oxygen is more electronegative than chlorine, and chlorine, it is the partial positive part of the molecule. Now students, here addition takes place according to Markovnikov's rule. Addition takes place according to Markovnikov's rule. What is the rule, students? The negative part of the adding reagent added to that double bonded carbon which have least number of hydrogen atom. Negative part of the adding reagent added to that double bonded carbon which has least number of hydrogen atoms. Now compare these two carbon atoms, right? This carbon, if this is carbon number 1, carbon number 2, carbon number 3. Here you can notice carbon 1 has 2 hydrogen atoms and carbon number 2 has just 1 hydrogen atom, right? So according to Markovnikov's rule, hydroxyl group, it will add it to carbon number 2, right? And chlorine atom added to carbon number 1. So after the reaction, we get the product like CH3, CH, OH, CH2, Cl, right? So in this way we get chlorohydrin. This is the example where Markovnikov's rule is applicable. I hope this reaction is clear to you, students. Now we will see the next important reaction of alkene, that is epoxidation. The next important reaction is epoxidation. Reaction number 6, epoxidation. In epoxidation reactions, peroxy acids added to alkene molecules and we get epoxy alkanes. Now per acids usually which are used are peroxyacetic acid or peroxybenzoic acid. Peroxyacetic acid, we know this is the formula of acetic acid, CH3, C double bond O, O, and then we have hydroxyl group, right? So this is peroxyacetic acid. Similarly, peroxybenzoic acid. What is peroxybenzoic acid, students? We know very well, with benzene ring, right? If we C double bond O, OH, this is peroxybenzoic acid. Right, students? You can write the structure like this, or you can also write the structure like peroxybenzoic acid can also be write C6H5, C double bond O, O, OH. Both the ways. You can write the structure like this way or like this way. Now let's see how peroxybenzoic acid is added to an alkene molecule. Let's take the example of a propene molecule. We have a propene molecule like CH3, CH double bond CH2. This molecule is a propene molecule. And here we have peroxybenzoic acid, C6H5, C double bond O, O, OH. Right, students? Now this addition takes place in the presence of a solvent that is known as chloroform, CHCl3. This is chloroform. After the addition of peroxybenzoic acid to alkene molecule, we get the product where oxygen form a cycle with the main chain. A product in which oxygen form a cycle with the main chain is known as peroxyalkane, right? Oxygen atom here usually added in the alkene molecule at the site of double bond, right? So after this reaction we get the product. Here we have the product CH3 CH2, right? Here this oxygen atom is removed from this molecule and it is added at the site of double bond, right? This is the site of double bond in the molecule. Here we have CH3. This is CH3, right? The name of this product is peroxy. Total number of carbon atoms are 1, 2, 3. So peroxypropane. Peroxypropane and peroxybenzoic acid simply changes to benzoic acid, that is C6H5 C double bond O OH, benzoic acid. Benzoic acid. I hope this reaction is clear to you, students.